Okay, let me finalize attendance. Yep, those are the notes. Wrong. In your hand. That one. Okay. So this is where we're going to continue today. You should have these notes. Take them out. Everybody should have them. If you do not have them, I don't know what to tell you. All right, I'll take that. Thank you. The homework I will also collect today if you have it done. If you don't have it done, I will accept it next time. Now, you did have enough information to get it done by today. But again, if you don't have it today, I will accept on Wednesday. Remember. Okay. Now, as you know, there's going to be a quiz next class. What I'm going to do, we're going to finish the notes from today. Maybe if time homework, but more than likely I'm going to probably do the quiz review. That's going to be the more important one. I think we may have some time to do the quiz review today. But again, beyond it, green on grass today. That's our game plan. So it looks like most of us are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, wow. Very good start for today. Okay. And homework, I'll probably have it graded for you by next time. Is that better? Okay, so that's our game plan for today. Finish Unit 5, Day 2 notes. Basically, it's going to be I will explain what was done as we talk about these notes. Oh, actually, some of them, let's see, I just want to make sure. Is this where we stopped? I feel like there's something missing. Oh, I think I might be missing a page by accident. Oh, that's not good. Okay, good. This is where we're supposed to be. Did we get through the first page?
No.
Got through the first page, everybody? Talked about proportionality statements, all that. Remember the order matters regarding both the congruent statement or the similarity statement. Remember the difference? Congruence, similarity, just that one little mark. I think that's where we. And then did we get through here too? We did this bottom part, right? Okay. So, you can't find them, Noe? Mm-hmm. No? Thank you. Thank you, Ms. Mann. All right. All right, so whatever's missing, you gotta get. But I don't think we didn't get through this part, right? Okay, we just started it. So, top of the second page. I think we started it, but we did not get far. All right. We'll go here. Make this a little bigger. Okay, now a couple of things you could do. You could label your polygons Up to you. You don't have to, but you can. You label A, B, C, X, Y, Z for your triangles. And then you have to pair them off. Now, in this case, we kind of have an idea on who pairs with what. Because notice how both of the triangles, the two longer sides are facing that way towards the bottom left. And then the shortest side is between the two longer sides. And we see that with this example. That's the most important part. Now, if you want to label, you can. Because if it helps you, I'm okay with that. So even if they're not labeled A, B, C, X, Y, Z, but if you want to label them to help you determine which side corresponds to which other side, go for it. I don't have a problem with that. Now, the most important piece of the whole puzzle is you need to know which two sides, which side from the first triangle corresponds to the second triangle, but both of them have to have numbers, values. And that's why I highlighted BC, YZ, because notice how they both correspond to each other. First triangle, second triangle. And then from there, you notice how, okay, BC and YZ, since they correspond to each other, this is a ratio you're going to use to help you find the other missing sides. Now, the other thing I can tell you, there's a way we can set up, there's a couple ways we can set up our ratio proportion. You can set it up with the following. You can do it with triangle 1. Oops, that's what I want to use. This is triangle 1. Notice here, this is triangle 1, right? The little triangle. Triangle 2, the bigger triangle. And then you could also do the following. On the top, you could say shortest side. Then, you know that here, VA, well, 4, 6, and 8. VA is at the middle because we have the numbers 4, 6, 8. This is your shortest, medium, longest. So you can do it the following. This is one way you can set it up. And then from there, you can figure out, okay, triangle number 1, my shortest side is BC, that's 4. Triangle number 2, my shortest side is 6. And for the median triangle, BA, that's my medium side length, that's also 6. But then YX, that's the medium side of triangle number 2. So that's one way. That's another way you can set up. You can try to figure out exactly who goes where in your proportion, like when you set up your table. Because the goal is you want to get here. Your goal is you want to get to this statement right here. You get there, then you're home free. We agree, we know how to solve for the variable. Again, let's put away them phones. We don't need them. We agree once we get to that proportionality statement, we're good to go, right? Because we know now how to solve for x. Because then that's where we do our diagonal multiplication or crisscross multiplication, 4 times x, 6 times 6, So yeah, 6 times 6, 236. 4 times x, 4x. And then from there, do your division. 36 divided by 4. 4x divided by 4. Boom. That's how we get the 9. And then you do something similar for the other problem. Now, the one difference is, again, figure out, okay, triangle 1, triangle 2, shortest. Okay, we have our medium side. X is 9. Now we need the longest side. Now you could use the medium as well, but I always keep it consistent. Look at the corresponding side that has both your numbers. Don't use, I wouldn't do, oops, I got the wrong variable here. That should be a Y. And then, there you go. Shortest, longest, triangle number 1, triangle number 2. There's your proportion set up. Boom. That's what we want here. And then you can figure out 4 times y, and then 6 times 8, you get 48 equals 4y. And then divide both sides by 4. Bang, done. There we go. So again, the number 1 is the setup. Get your setup first. You get the setup, then you're home free. So that's what we're going to practice. Setting up our proportions. Given the diagrams. Questions? I know once we're here, you know exactly what to do. All right, questions before we talk about part B? Because part B is a similar situation. But here, you got to get this part. Set it up. Highlight which two sides, which side from side 1 corresponds, which side from triangle 1 corresponds to which side from triangle 2. Now, you could have done it with all 3 as well. Like, I'll show you what I mean. Oops, wrong way. I'm going to show you what I mean by that. And we talked about it last time. Like here, again, we could have done triangle number 1, triangle 2. Now, what we could do, just to make sure, some of us might do it like this. Might go A to B, B, C, C, A. You can always do this. And then look at the second triangle, figure out which sides from the second triangle correspond to the ones on the first. So for instance, AB, which side corresponds to AB? So give AB, that side far left. Which side in the second triangle is going to correspond to AB? Who can tell us? Which side also goes up and down? Here's AB. Now look at triangle number 2. Which side, just like AB, goes up and down? XY. Which side goes from left to right, or horizontally? If it's BC, which side in the second triangle goes horizontal? BC and, well, two letters are right here. YZ. Then, of course, diagonal, diagonal. That probably would have been the easiest one. But again, you have to figure out triangle 1, triangle 2. A lot of times we'll do figure 1, figure 2. And then write down your sides. But you have to get this part first. And then what I tell everybody, you could also label. We don't know what AB is. Well, it's X. But XY we know is 16. BC. YZ. BC is Y. YZ is 12. And then CA. 10. XZ. 20. Now, again, we highlight the one that has both numbers. So does AB and XY, do they both have numbers? Does AB have a number? Yes or no? Does AB have a number value? No. Can't highlight that one. Does BC have a number? No. Can't highlight that one. So by process of elimination, which ratio are we highlighting? Which one has both a number on the top and a number on the bottom? We can't. This one doesn't have a number on the top. This one doesn't have a number on the top. This one does. Now remember, CA and AC, can we switch the direction? Can I also write CA as AC? You can. And then since both AC and XZ have the number, this is the proportion we need. We're going to use to help us get the other two. Now, on the bottom, notice how we wrote AC over XZ. Could I have switched this around? Could I have had X over 16 equals 10 over 20? Can I write it the other way as well? Like, I'll show you what I mean by the way. Let's say if I flipped it, AB, XY, 10 over 20. If I wrote it this way. Are these two proportions the same? Are those two proportions the same? In the end, what I wrote here, what I wrote there, are they the same? Yeah. In the end, they're the same. So it doesn't matter. If you wrote 10 over 20 equals X over 16, X over 16 equals 10 over 20. You got the same thing. Everybody still corresponds. Because here you still have figure 1 on the top. We'll call it triangle 1. And triangle 2 is on the bottom. Triangle 1, triangle 2. And then you could also, in this case, you have the longest. And I think that's the medium. And here you have the longest and the shortest. Or you could have done it this way. And there's several ways we could have done this. The goal is I want us to understand the connections. We need to understand connections between diagrams, equations. I can't say that enough. I've been saying that in and out all year. Do we agree? Diagram tells us the equation. That's our connection. Again, same thing up here. Boom. If you wanted to do it like this, and then separate it, this will get you your first one. Actually, let me do that. There's one of your proportions. And then your other one, you could have done it, the other one, you could have done it like this. You could have used this one with this one. You compare them two off. So you could have paired them two off first, and then paired off them two. Again, the goal is getting the connections. Understanding the connections, and then solving that proportion. And then, of course, once you get here, then it's all about your diagonal multiplication. 10 times 12, y times 20. All right, check if you have your notes from last time. If you don't, then you're going to have to get paper. Copy things down. And same thing here. Do your diagonal multiplication, and then solve your missing variable. All right. So up here now, check if you have your notes. If you don't have them, then you're going to need paper. You're going to have to copy things down. And I have a pencil on the back. All right. Questions on how set up and solve our proportions. And we're going to practice this again and again throughout the rest of today. Again, I can't stress it enough. You have to get the connection to set up. You don't get this set up right, say goodbye to your problem. All right. The other thing we're going to start talking about too is called the scale factor. Basically, it's your ratio, but you're going to multiply a number from one side to get the other, or vice versa. And we kind of see it here. We've kind of seen it already. So we know from one number, you think we need to multiply by 10 to get 20. What number times 10 gives us 20? 2. So we kind of been dealing with the scale factor already. And then similarly, if we went from 20 to 10, we divide by 2. Well, and then there, of course, there's another way to say that. You divide by 2, or you multiply by 1/2. So either way works. That's straight through. You're already done.
That one didn't count, remember?
Let's see.
We didn't count it.
All right, well, now you're at number 3.
Yeah.
That's it. So, hold on, I gotta.
Is that a computer? I don't know once I can
Well, you can't worry about her right now. You gotta worry about you. Don't worry about her. Shouldn't be texting. All right. So scale factor, basically whatever, you're gonna multiply the same number for all 3 sides or all 4 sides from one polygon to get to the other, and vice versa. Don't worry so much about perimeter, similar perimeters. I mean, it's gonna be the same. Don't worry about that part as much. I'm worried more about the scale factor. You need to figure out what number. We'll talk about it here. So basically, you're figuring out what number do we multiply from the first polygon to get to the second polygon. You multiply by something, and vice versa. You're going vice versa. You're going to multiply by some number. You go from here to here. We'll figure that out momentarily. But that's our goal.
Yes, do we copy all of that down?
Copy all what down?
Like where it says,
The congruent angles?
Yeah.
Yeah. And this proportionality statement. I will copy that down. And the reason, but I'll explain how we got this. And then I'll talk about these arrows, like multiplying by some number to get to the other, and vice versa. Now again, congruent angles and proportionality statement you get from your similarity statement. They both come from here. You look at the similarity statement. That's what both congruent angles, proportionality statement. You get that from the similarity statement. You get them both from here. You get them both right here. Again, just like the congruent statement, take your letters from the first polygon, write it above or write it below the second. And then you see exactly which angles pair off with each other, which sides pair off with each other. And I'm going to talk about why I chose this side, the KL and the QR first. Because as you see, KL and QR both have numbers. They both have numbers. Because then this is going to help us find the missing variables and also the scale factor. But I'm going to tell you with the scale factor, and we really need to pay attention with the scale factor because the direction is going to switch up a little. But with the similarity statement, everything's going to be in order. Now, one thing I will say, if with the similarity statement, if I had inverted it, if I put the QR above KL, RS above LM, SP above MJ, PQ over JK, would you still have an okay with the proportionality statement still work? If I flipped everything.
Yeah.
It will work. You're right, Cindy. So you could have wrote these letters, although these letters in the order, you still would have an okay proportionality statement. Everybody still matches appropriately according to this similarity statement. So you are right. Now the most important part, you have to figure out, that's why I tell everybody, get the proportionality statement. And then pair off, like look at, okay, KL is 15, LN is X, MJ is Y, JK 25. But then look at QR, okay, 12, RS 10, SP 16, P to Q, W. However, if we look at our proportionality statement, KL and QR, notice how they have a number both above and below the fraction bar. Do we see that? Do we understand that? That's the most important part. That's why I highlighted it. This is going to be the part that's going to help us get the scale factor and also determine the value of the missing sides. You got to get that part. You don't get that part?
I already got that one.
I know you got that part. I'm glad you got that part. Good. If you don't get that part, you're not getting any of the other parts. So I didn't say, I wasn't directing that question at you, Dennis. Now, with the scale factor, this is a clue. And I'm going to tell you, you're going to lick. You know how we wrote going from one way to the other? You know how I usually say you write the first to second? Like if I said A to B in words, that meant A to B as a fraction. Or so we all agree. These three expressions mean the same thing. Okay, with the scale factor, you need to flip it. And I'm going to tell you why. Notice the order. And there's going to be a similar problem on your quiz review. And I'm going to tell you, PQRS, is that the bigger or the smaller figure? Is PQRS bigger or smaller than JKLM? Look at the two figures. Is PQRS bigger or smaller than JKLM? Smaller. Okay, so now when we go from a smaller to a bigger figure, smaller to bigger, it's always going to be, your scale factor is always going to be larger than 1. So that's the thing. Scale factor, if you go smaller to bigger, in fact, that, I'm going to have everybody, I apologize, well, we'll write it somewhere shortly. This is why I tell everybody, you're going to have to flip. Because if you kept it the original order, you would get a smaller number, and that's not what we want. Or vice versa, if we went from JKLN to PQRS, are you going bigger to smaller? Now we're going opposite direction. We start here. We go here. Are we getting bigger or smaller? Start from the left, go to the right. Is that bigger or smaller? You're getting smaller. So if you're getting smaller, your scale factor will be less than 1. And I'm going to write that, in fact, I'm going to write that down. Let's write this down. So if you go from bigger to smaller, bigger, or we'll say big to small. The scale factor, we'll just abbreviate it. SF for scale factor. Less than 1. You're going from the bigger figure to the smaller. Scale factor, less than 1. You went from bigger to smaller. Oh, I guess I thought it was actually too locked. Okay. Sorry about that, Eric. So you went from bigger to smaller. Your scale factor is less than 1. So if you went from smaller to bigger, I'll just write SM bigger. If you went smaller, bigger, then your scale factor will automatically be greater than 1. So that's the most important fact I want you all to understand. And on your quiz, you're obviously going to see the quiz problem that I'm going to give you. You're going to obviously see. If I tell you scale factor, you obviously will know if you're going big or small, or vice versa. So if you're shrinking or getting bigger, you know exactly what your scale factor should be. So that's important. And then basically, what's going to happen, so if we go smaller, so if we start at 50, so if we look at our corresponding sides, I'm going to highlight the corresponding side here. KL to QR. If we're going from KL to QR, did we get bigger or smaller? 15 to 12, is that bigger or smaller? We go from 15, we start here, go to 12. Is that bigger or smaller? Smaller. So then what we have to do, take that 12 over 15, and that's where the calculator comes into play. Yeah, there should be some back there. So 12 over 15 is the same as 0.8. That's where we get that. That's why I tell everybody, flip it. You know you're going bigger to small. Put the smaller number on top, divide by the bigger number. You can't get a decimal. You could get a fraction as well. I'm okay with it. And then vice versa. If you're going from smaller to larger, you're going from 12 to 15, put the 15 on the top. And then the 12 on the bottom, which 15 divided by 12 is 1.25. So that's how we're going to determine our scale factor. Look at the direction. You go bigger to smaller. Small number goes on top. If you go, or the second number, your final destination goes on top. Starting destination on the bottom, vice versa. Final destination over starting point. That's what we got to do. And we'll practice this a little bit because there's going to be another problem. We're going to practice this. Now, going back. All right, questions on the scale factor. And we're going to practice this a little bit. I think there's another problem. A couple problems we're going to practice. Again, look at your direction. You're going bigger to smaller. Scale factor is less than 1. You're going smaller to bigger. Scale factor is greater than 1. That's what I'm going to tell you. That's the most important piece of information. All right. Now, to find out WXY, again, use your proportionality statement. Don't worry about question F. proportionality statement.
The famous.
Use your proportionality statement. That's from up here. But the highlighted one is the most important one. You're going to use that 3 times. If you haven't done so, you're going to write it down, and then I'll give it to you. The proportionality statement, remember, you get that from up here. But remember, you're going to have to do this 3 separate times to get your result. One reason why we highlighted this one, you need that KL over QR. It's going to help you get the missing value for all 3 cases. But also notice, again, keep consistent. Figure 1 on the top, figure 2 on the bottom, or vice versa. You can put figure 2 on the top, figure 1 on the bottom. If you want to go larger or smaller, that's fine too. But remember, again, proportionality statement comes from the similarity statement. You understand this? You get that. I do not want that right now. Sorry about that. And then from here, there's your setup. And then from there, do your diagonal multiplication. Boom. Do your diagonal multiplication. Same thing here. Boom. Boom. Again, I'm not going to stress as much about the proportionality statement. Well, once you get here, I'm not going to stress as much about finding the variable. We've done plenty of practice. I just want us to understand the connection. The connection is also important. This gives you these guys. I'll put it back down in a second. Again, this gives you this, that, and it will eventually, whoops, get you everything else. And then again, if you need to, the side, the ratio that has both numbers is going to be the one you will use for scale factor.
Yeah. Yeah.
Okay.
Yeah, because
Stop.
they say that I'm always skipping.
Okay. Can we not worry about that conversation for now, please? Okay.
No, both of his fingers is superior and I think the rest of it.
All right. Here we go.
I'm gonna go right.
Any questions on this proportionality setup? Because once you get the proportion, you know how to solve for the variable. We've been over that several times. I'm not going to worry about that anymore. Remember, it's got to say. All right, now what we're going to do. Okay, hold on. Any questions on these notes? Because the other ones, we're going to fly right through them. Everybody understand about the proportionality statement? Finding variables, scale factor. Okay, listen. Hide the phones. We don't need that. Are we okay with this? About 10 seconds, I'm going to move on. All right, just want to make sure. Again, similarity statement, issue angles, proportionality statement, scale factor. And that's what we're going to do for the majority of the rest of this period. Okay, here we go. All right. So I think this is page number 3. All right, so here's what we do. Okay, does it matter if I write A, B, C, D above or below G, H, I, J? Does it matter? No. All right. Congruent angles. So, which angles are we going to pair? So, angle A is going to get paired with what angle? What letter's right below A? Okay, J. Okay, we really need to focus on what's going on here. You're going to see this soon. B gets paired with what? Which angle?
X.
X is not even a possible option. It's H.
Well, I thought we were looking at the shapes.
Nope.
Oh.
Right here, you got to
I
again.
thought we were looking at the shapes.
All right, well, let's look here first, and then we're going to talk about that. C pairs with what? What's right below C? What letter? And then D and J. So there's your angles. Now proportionality statement. All right. Which side's going to pair off with AB? Which 2 letters are right below AB?
GH.
Okay. BC is going to pair off with
HI.
CD. Pairs with JI. And then DA. Who's pairing off with DA? JG. All right, now. This is why the proportionality statement is going to be most important. AB is what number? I mean, how long is AB? 8. GH is how long? Well, do we know what GH is? Okay, we don't know it yet. What about BC? How long is BC? Okay. Okay, we don't. HI, who wants to take a guess as to how long HI might be? Whoever said 5.5, very good. GJ and HI are going to be congruent. So that's 5.5.
The congruent means same, right?
Yes. Congruent measurement, same measurement. Congruent, same measurement. Yep. Okay, CD. How long is CD? X. What about JI? 8. JI, IJ, the same. JG? DA. All right, now, you have a couple options. Which ratio has a numerical value above and below? You have a couple options. Somebody just pick one. But what's below AB? You going, you got it. BC and? Okay, I'm going to highlight this one. You can highlight this one. I mean, we also could have highlighted DA and JG. Either one would have worked. But here's why we're going to highlight this one. Now, scale factor. Question. We're starting at ABCD, going to GHIJ. Are we getting bigger or smaller? We're getting bigger or smaller? You're getting smaller. So if you're getting smaller, then is our scale factor larger or smaller than 1? We're going from a bigger to a smaller figure. Is our scale factor going to be greater or less than 1? Less than 1. Very good, Adrian. Smaller, you're going. So bigger to smaller, you're getting smaller, so yeah. Now, what did I also say with the scale factor? Are we going to keep the order or do we flip it? Flip. So G, H, I, G, H, I, J, over A, B, C, D. Now, out of the, which letters, look at our proportionality statement, which letters were highlighted? Look at our proportionality statement. Which 2 letters were highlighted? Good. So that means we're going to use this ratio to give us our scale factor. Now, HI, what was the measurement of HI? Look at HI. What was our measurement? Look right here. 5.5. What about BC? What's our measurement of BC? BC is, okay, take your calculators. 5.5 divided by 11, what do we get? Okay,
0.5.
0.5. Did we get that in this calculator?
Yes.
Really? That calculator wasn't even open. I don't know how you pulled that off. 0.5. So that's our scale factor. So if you multiply 11 times 0.5, or, well, what's the fraction equivalent of 0.5? Be careful. What's the fraction equivalent? 0.5. Anybody want to take a guess? It's real easy. It is 1/2. or 1/2. I would have accepted. Okay. Questions? All right, what about the opposite direction? So we're going from GHIJ to ABCD. So are we getting smaller or larger? Getting larger. So therefore, scale factor, smaller or larger than 1? If we're getting larger, is our scale factor larger or smaller than 1? It's going to be larger than 1. It has to be. Okay. Again, are we keeping or are we flipping this order? Scale factor. What happened? Did we keep this order or did we flip it? You had to flip it. So therefore, scale factor. Keep the order or flip it? You have to flip it. Again, here's where the highlight, what 2 letters were highlighted up here? Good, boom. So keep whichever was highlighted. You can highlight or cross out whatever was not highlighted, that's fine. Boom. There you go. Use that proportion. BC was 11. HI was 5.5. What's 11 divided by 5.5? 2. And is our scale factor larger than 1? Yeah. So here, you go from here to here. You go from small to larger, you're going to multiply by 2. And actually, you know what? That's going to help us. I mean, we could use a proportionality statement as well to determine our missing values, which I think is probably better. But now we're at a point where we want to find the values of x and y. Now again, if we're going to find the values of x and y, which one of our which ratio are we using right away? What's going to help us? Which one did we highlight? Look at our proportionality statement. Which ratio was highlighted? What 2 letters? Right here, look what we've highlighted. BC and HI, right? You can use that one in both cases. Again, use proportionality statement. Proportionality statement. BC. HI. Now, that's going to be 11 over 5.5 equals, okay, which ratio has, look here, which ratio has the x? Which one do we see in x? Where's the green x located? Which side? Look on the top. CD. CD, and which side's on the bottom? JI. Now you have x over 8. You see where we're going with this? All right. Now, oh, that's wrong. Sorry about that. Okay, here we go. Okay, now, anybody try to figure out what that x is? Anybody get a value of that? You're close. Watch your decimal point. Would it be 1.6 or would it be? You're on the right track. It's close. Well, what's 11 times 8? Let's do that real quick. 11 times 8 is 88. And then what's 5.5 times x?
Oh, never mind. I did 55.
Okay, that's not your fault then. Because then you saw what would have happened, right? You did 88 divided by 55. All right, not your fault. That's okay. It looked like 55 from here, so you had the right idea. So in the end, 16 is going to be your x. Yeah. Thank you. Not my class. Oh, by accident. I've been to it. All right. Looks like you gotta go now.
Word.
No, man.
All right. Now, we found x. We're gonna do the same thing, find a y. Use this part right here. Because notice GH is the value of y. That's what we get from up on the top. Okay. BC and HI, we know BC is going to be 11. HI is 5.5. And then AB, 8, GH, Y. So now we're going to figure out, let's get this proportion real quick and then we're going to move on. So you should check that out.
Doing that thing on the phone. Like, I don't even know why I have. It's just a big fan I gave up from my mom.
Okay, here we go. What do we get for y? You can tell us. What do we get? Anybody? Anybody? All right, I'll make it real easy. What's half of 8? There you go. It's going to be, because if we go from bigger to smaller, you can just multiply 8 times 1/2 or divide 8 divided by 2. Y is going to be 4. That basically comes from the scale factor. So if you had the scale factor, that's also going to help you. Because in the end, you have to multiply.
What does that say next to the purple letters?
Use proportionality statement right here. You use the proportionality statement. You gotta use that. That's how you're gonna get everything. And then you do your diagonals. And 8 times 5.5, that's 44, equals 11 times y. And then that's how we get the y equals 4. Once you're here, there's no excuse to get that incorrect. None. All right. Questions at this point? All right. Yeah, these next couple problems are going to be super easy. How do we decide whether or not polygons are similar? Well, basically, you're going to pair your sides. Now, there's 2 ways you can get these. Now, if you want to do A, B, C, D, and then W, X, Y, Z. You can do that. And now you're just going to pair off your sides. Or you can pair it within. This is the first rectangle, second rectangle. This is basically just figuring out how we're going to set up. So, all right, one way we can do it. Because you could also go length, or width, I'm sorry, length, width, the length. You can do it that way too. And you can do it like this. So, I'll show you a very simple example. Length, width, and then it's number 1, number 2. That's one of the quickest ways you can get this problem. What's our length for the first rectangle? What's our length? What's our length, ladies and gentlemen? Length of the first rectangle. What's the longer side? Length of a, what number's bigger in the first rectangle, 10 or 14?
14.
Okay, then the width has to be? Okay, what about the second? What's the longer side in the second rectangle? Shorter side. That's your width. Okay, do your diagonals. Cross multiply. And then check if you get the same product. Or you can just divide the two numbers, see if you get the same result. Anybody need a calculator? Pass that back to Joey, please. Well, what's 21 times 10? 210, good. What's 14 times 15? Okay, since the products are the same, are they similar? Yeah, similar. What about number 2? There's your length, there's your width. Width, length. Set it up. Okay. That's the number 1. Number 2. What's our length for the first? What number?
26.
Okay. What's the width of the first one?
18.
Length of the second one? Width of the second one?
25.
All right. Now, do our diagonals. Are they going to be the same? Who said no? You're correct. They're not. So, are these two going to be similar? No, not similar. Not similar. So I think 36 times 25 was what? Everybody get that product? How much? All right. And then 45 times 18 was what? 720? Say again? 18. Yeah, I knew it was. All right. So it wouldn't matter. You're right. So in the end, they're not going to be similar. Diagonal products, not the same, not similar. All right, number 3. All right, this one is not going to be as bad as it looks. Let's say this is the first, second. All right. Here's what you can do. What's the longest side in our first? So we're going to focus on the 2 parallel sides here. Or actually, I got a better idea. In the first ratio, actually, I'm not going to do 1 and 2. I could. What's the longer of the 2 parallel sides? What's our longer parallel side? What number? So go long. Or you can do longer, shorter, shorter, longer. So what's our longer of the 2 parallel sides? What's our longer side? Or actually, I got a better idea. Boom. Let me do it this way. So this way. 1, 2. Pick a side on the first trapezoid. Pick any side you want. I got a better idea. Pick any side you want on the first trapezoid. Pick any side. All right, Cindy. Pick any side on the trapezoid. Pick any number you want.
25.
Good. Okay, in the second trapezoid, which side's going to match with the 25?
32.
It's the 20.
Oh, it's flipped.
Yeah, that's why you got to pay attention.
Oh.
That's why we got to be careful. It's flipped. So the 20 matches with the 25. All right.
Really flipping this stuff same.
Well, that's why you gotta be careful. 25 and the 20 match. Now let's look at the other one. Pick another side.
40,
Who matches with the 40?
32.
Okay, you can set it up this way. Now do your diagonal multiplication. Boom, boom. See what we get.
They're both similar.
They're similar. Yeah, you're gonna get the same result. They're both gonna be what? 800? Yeah. These guys are gonna be similar.
No.
All right. What do you need? What type of work do you need?
I think it's 45 by anywhere, it's 45 by like what you like this in I only wear sport bras when I go to like outside the school and
Oh, wait a minute. I got a better right here. Boom. Take it.
I do.
You got them all right here. Boom. These are all yours. Don't. I'll take that back.
That's me.
Those are all yours. All right. Thank you, Christian. Okay. Number 3 is similar. Good. Questions? All right. Next page. I'm going to try to make it very quick. All right. Here's what's going to happen. I want to talk about a couple things and then. All right. For these, what's going to happen? EF, that's our missing side. That's what we want to find. Now, if we're going to go from scale factor, we're going to go from left to right. So we go from, are we getting bigger or smaller? If we're going from the left figure to the right figure. Okay. What did we divide 12 by to get 6? What number can we divide by 12 by to get 6? 12 divided by what? Gives us 6. 12 divided by something is going to give us 6. We can figure that out. What number?
2.
2. 12 divided by 2, you get 6. So if we go from bigger to smaller, our scale factor, well, of course, it would be 6 over 12, which would be 1/2. So that means we divided by 2. Now, or multiply by 1/2. Now, you do the same thing going from the bigger to the smaller. So we start with 13. You divide by 2 or multiply by 1/2. You're going to get decimal, but what will we get? What's 13 divided by 2? 6.5. So we went from bigger to smaller. That's why we get 6.5. No, less than 1. All right. Now here, real quick, we're going to go from left to right. Are we getting smaller or larger? From here to here, are we getting smaller or larger? Larger. So, what do we multiply 5 by to get 10? Somebody said it. 5 times what gives us 10? 2. Similarly, what's 10 divided by 5? 10 divided by 5 is 10 divided by 5. So, all right, now, so that's your scale factor. So now, when we go from 1.5 to this x, when we multiply, what's 1.5 times 2? What's 1.5 times 2? 3. X is going to be 3. Again, don't worry about the perimeter. There you go. All right, here's what I want to do. I know we only have a few minutes left. These are basically going to be the same thing. I'm going to just give you the values.
No.
What I want you to do, what I want us to do, don't worry about the perimeter. I don't know if we might run out of time. I'll try my best. Sorry, this is all going to be rush. All right, 7, don't worry about too much. You know what? If you understand 1, or 5, 6, and 8, that's fine. 7, you're not going to get something as crazy as this. Because, all right. Okay, before you go, 2 things. Thing number 1, this example, draw a picture. We'll talk about it real quick. Now, here's the other thing I want. We're gonna pass out the quiz review. Okay.
I know, right?
I need everybody, listen up. On your quiz review, we're gonna go to the back real quick. I want us to go to the back. The last 2 pages, I need you all to do something. So where it says problem 13 and problem 14. So problem 13, I'm going to switch the order. A, B, C, K, L, M, you have to switch. And that's going to be the same on 14. Switch the order. Switch the order of the letters. Switch the order of the letters. 13 and 14, you got to switch the order of the letters to get this right. Now, there's going to be a little bit of time at the beginning of class. I'm going to talk about that final problem from number 2, from day 5, day 2 notes, along with the word problem for number 15, for the very last problem on this review guide. Everything else should be the same. Everything else you've done. Basically, if you know how to set up your proportions, you know how to do that, you should be A-okay. And again, put your first letters over the second. You should be able to do well on this quiz. Anybody, final questions for me? And we'll review a little bit of it. Quiz. All right.